Now in this example we have the integral of x root 3x minus 1. And when you're dealing with integrals like this that have a square root, what we can do is take two possible substitutions. We could let u equal 3x minus 1 or u squared equals 3x minus 1. Now in this tutorial I just want to show you what happens when we let u equal the 3x minus 1. However, you might want to go to my other tutorial where I demonstrate u squared equals 3x minus 1 and compare the two methods. So, for this example then, if u equals 3x minus 1, we need to get dx du. So I start by differentiating this with respect to x, so du by dx would equal 3. And then, to get dx by du would always be equal to 1 over du by dx, so that becomes 1/3. So according to the formula up here, we've got our integral of f of x dx, this is the f of x, becomes the integral of f of x, so that's x root of 3x minus 1. And then we have to insert dx du, so dx du is 1/3, so I'll pop that in brackets, and then we integrate with respect to u. Now we need to change the variable completely over to u's, and so in this example the x here has to be expressed in terms of u, so I can see that from above here that if I add 1 to both sides I get u plus 1 equals 3x, and so divide by 3 we have x equals u plus 1 all divided by 3. Or I could regard that as 1/3 of u plus 1. So we have u plus 1 then over 3 for the x. Now here we have essentially the square root of u, because u is 3x minus 1. So I can write that in as u to the power 1/2, half being the square root. Then we have the third du, so write that in there. Okay, so this looks a bit messy, so what we need to do is just clean this up, and here I have essentially 1/3 with another third, so that's going to be 1/9, and it's best if we take that out the front of the integral. And then I'm left with u plus 1 multiplied by u to the 1/2, which I'm going to expand. So u to the power 1 times u to the 1/2 is u to the power 3 over 2. And then 1 times u to the 1/2, that's going to be u to the power 1/2. Got a couple of terms here, so make sure we put that in brackets and then integrate with respect to u. So I've cleaned this up now, and now it's in a position where I can integrate these two terms. So I put the 1/9 down and then have a bracket, and in the usual way add 1 to the power, so that's u to the power 5 over 2, and divide by the new power 5 over 2, so that becomes 2/5 when it's cleaned up. Similarly, we have this term, add 1 to the power, that becomes u to the power 3 over 2, divide by 3 over 2, which in effect is 2/3 times u to the 3 over 2. And don't forget the constant on the end. Next, what I want to do is put this all over a common denominator, so the lowest common denominator in this case would be 15, so I have that over 15. Turning 2/5 into 15ths, I need to multiply top and bottom by 3, so that would be 2 3s are 6, 6u to the power 5 over 2. And in this one I need to multiply top and bottom by 5 to turn 2/3 into 15ths, so that's going to be plus 10/15ths, and then we have the u to the power 3 over 2 on the end, and then plus the constant of integration. Next, what I can see on the top here is that I could pull out a common factor of 2u to the power 3 upon 2. So if I pull that out, we've got 2u to the power 3 upon 2. And in the denominator here, I could do the 9 times the 15, which would be, what, 135, so that's over 135. And then I've got simply, to make 6u to the 5 over 2, I need another 3u. And then for 2u to the 3 over 2 to make this term here, 10u to the 3 over 2, I just simply need 5. Okay? And then plus c. I always find it's better to simplify at this stage rather than put my u back in as 3x minus 1. Less work to do. Okay, let's just finish this off. We'll move that up like so. What have we got now? We'll just copy this in and replace our u with 3x minus 1. So we have 2 lots of 3x minus 1 all to the power 3 over 2, and then this is over 135. And then seeing that I've got 3 lots of 3x minus 1, I'm going to put a square bracket up here because I'm going to have brackets within brackets, so that's 3 lots of 3x minus 1, and then plus the 5 on the end, and don't forget the constant of integration. Okay, so we're nearly there now, so we've just got to clean up the square bracket, so write that in here, 135. Now when it comes to square bracket, we can see that we've got 3 lots of 3x, that's 9x, so have a curved bracket now, 9x, and then we've got 3 times minus 1 is minus 3, plus the 5 is plus 2, so 9x plus 2, and then the constant of integration plus c. Okay, so there we have it, the answer to our integral. Quite a lot of work, but nonetheless, using this substitution, we were able to complete the integral. As I said earlier, I've done this integral again in another tutorial, only using u squared this time as being 3x minus 1. And what I'd like you to do is have a look at it, and you'll see how different the amount of working is. Okay.